US Physics Olympiad, year 2014. F equal MA, first round. This round consists of 25 problems for 75 minutes. All solutions for these problems you can find in the description reference below this video. Please subscribe for this channel. In that case, you will have opportunity to get many interesting Olympiad level and other hard level problems in physics. Problem 1. A car turning to the right is traveling at constant speed in a circle. From the driver's perspective, the angular momentum vector about the center of the circle points x and the acceleration vector of the car points y. What is the direction of x and y? Solution. First, let's draw the picture. Let's say this is a trajectory of our car and the driver going clockwise with the velocity v. Now it's going up and the radius vector is going to the left and the centripetal acceleration going to the center. By definition, angular momentum equal this expression. That's a cross product of radius vector and momentum. Using right hand rule, we can find that direction for angular momentum is going down inside the page. So that's the answer. If we can see, correct answer is E. X is down and the Y is right. Problem number 2. A ball rolls without slipping down an inclined plane as shown in the diagram. Which of the following vectors best represents the direction of the total force that the ball exerts on the plane? Solution. Let's see which forces acting on the ball from this triangle and to the triangle from this ball. Because force friction going opposite to the motion of this ball, the same force going downhill from ball to this triangle, and normal force from the ball is going perpendicular to this incline, which is N. So we see that net force is going down and slightly left, which is correct answer E. Problem 3. An object of uniform density floats partially submerged so that 20% of the object is above the water. A 3 Newton force presses down on the top of the object so that the object becomes fully submerged. What is the volume of the object? The density of water is 1000 kilograms per cubic meter. Solution. Additional buoyancy force acting on a submerged object equal to this expression. From here we can find what is the volume. It means the volume equal 1.5 liters, which is answer D. Problem number 4. What are the correct values of the numbers in the following statements? Assume there are no external forces and take n equal 1 to mean that the statement cannot be made for any meaningful number of particles. If a particle at rest explodes into n1 or fewer particles with the known masses, and the total kinetic energy of the new particles is known, the kinetic energy of each of the new particles is completely determined. If a particle at rest explodes into and 2 or fewer particles, the velocities of the new particles must lie in a line. If a particle at rest explodes into n3 or fewer particles, the velocities of the new particles must lie in a plane. Solution. Certainly n2 is at most 2 and n3 is at most 3. It is certainly possible for 3 particles to emerge with non-collinear velocities or 4 to emerge with non-planar ones. Consider, for example, the case where all of the particles have equal mass and they emerge at the corners of a triangle or tetrahedron. However, note that the total momentum of the daughter particles must be 0. It is impossible for 2 non-collinear vectors to sum to 0, nor 3 non-collinear vectors. Thus, n2 equal 2 and n3 equal 3. Meanwhile, n1 is at most 2. Consider 3 identical particles where, among many other possibilities, any one could emerge at rest with the energy split equally among the other 2. In the case of 2 particles, the velocities must be in opposite direction and, as argued, in a straight line. Thus, up to overall direction, they are entirely determined by the kinetic energies. There are 2 independent equations governing the kinetic energies. The total momentum must be 0, and the total kinetic energy is fixed. Thus, the kinetic energy are fully determined in the case and n1 equal 2. So, correct answer is C. n1 equal 2, n2 equal 2, and 3 equal 3.